This is practice problem 6.5. I've got a table that shows 4 data sets prepared by a statistician to show the dangers of calculating without first plotting your data. So I've got 4 sets, set A, set B, set C, and set D. For each set I've got 11 individuals, each with an X and a Y value. And for part A, I want to find the correlation value to 3 decimal places and regression line equation for each data set using these online calculators. And I've got the websites here on the slide. And we want to use the regression line equation once we've found it to predict y for x equals 10. So I'm going to go over to my calculator here. And this is the correlation calculator. And I've added a bunch of boxes so that I have enough for all my data. And I've entered the x and the y value for each of my individuals in data set A here. And then I'm just going to click on calculate. It tells me I've got 11 individuals and that my correlation is 0.816. So that's a pretty strong correlation value. Next, I'm going to go over to the regression line calculator, and I've entered the same x and y values for dataset A in here. I click on calculate. Again, it tells me I've got 11 individuals, and that the equation for my regression line is y equals 3 plus 0.5x. So let's go back over to my slides here. And on the next slide, I've written down that correlation value R is equal to 0.816, and the equation for the regression line, y is equal to 3 plus 0.5 times x. And then I've also used that calculator to find the correlation values and equations for regression line for all of the rest of my sets A, B, C, and D. You can see here that we've got exactly the same correlation value for each set, and pretty close to the same regression line equations. They're just off by 0.001 or 0.002 here. So let's use each of these to predict the y value for x equals 10 for each regression line. So I'm going to start out with set A. If x is equal to 10, then y is going to be equal to 3 plus 0.5 times 10, which is equal to exactly 8. For set B, if x is equal to 10, y is equal to 3.001 plus 0.5 times 10, which is 8.001. For set C, if x is equal to 10, y is equal to 3.002 plus 0.5 times 10, which is going to give me 8.002. And then for set D, I'll have the same thing. When x is 10, y is going to be 3.002 plus 0.5 times 10 is 8.002. So these all look very nearly the same in all of these respects. Now let's take a look at their scatter plots. So here I've got the scatter plots for each of the data sets labeled with their name. In which case would we be willing to use the regression line to describe the dependence of y on x? Well, let's look at set A. I've got all of my points here kind of scattered about my regression line. I don't have any outliers that are far away from the line, and it looks like the line is a pretty good way to describe the dependence of y on x. If I was looking for the value of y when x is equal to 16, I could just go on my line here at x equals 16 And if I guessed that point there, I'd say that's a pretty good guess. What about set B? Well, I've got the same regression line, but the points in my scatter plot kind of make this curve here. So they don't really follow the line, they follow more of a curve. So if I was to use the regression line to guess what the value of y is when x is equal to 16, I would guess the same as I guessed for set A, and I guess up here. But that actually doesn't look like a very good guess. If I wanted to follow the curve of the data, a better guess would probably be somewhere around here. So that regression line is not a very good way to describe how y depends on x for set B. What about set C? Well, I've got one outlier here, and it looks like if I got rid of that outlier, then all of the rest of my points lie on a line that's not quite my regression line. They're on a line that's more like this. So that looks like that regression line is also not that good of a predictor. If I was going to guess the value of y when x equals 16 on my regression line, I'd guess the same thing as for the other sets, but a better guess would probably be down here on this other line that it looks like most of my data follows. Finally, let's look at set D. Here I've got all of my points stacked vertically on top of each other, except for this one outlier, which is bringing the regression line out like this. So if I ignored that, then all of my points would be on this vertical line going straight down at x equals 8. So it doesn't look like that's a very good way to predict the y values either using the regression line for set D. So the only one where I would trust the regression line is set A.